Hello everyone, this is Karen Villabanca, and this is the project initiation and planning presentation for Group LARK. Today we'll walk you through the essential steps in getting our project off the ground. First, we'll have Luke provide insights on the problem definition and the scope of work. Then Raul will delve into the details of our feasibility assessment. Following that, Alex will explain the work breakdown structure and the per chart. And lastly, I'll present our Gantt chart outlining the project's timeline.
Hello, I'm Luke Somerset of Group LARK. Today I'll be describing our software project for you in two ways: defining the problem our client faces and outlining the scope of the work we'll do on this project. In the words of our client, the collection spans different historical eras, covering different technologies that operate in sky, sea, or space. Items in the collection may include ephemera, which refer to miscellaneous items like brochures, menus, or newspapers, dinnerware and silverware, uniforms, aircraft, ship, or space artifacts, aircraft, ship, or space models, books and magazines, technical manuals and documents, and video and audio recordings, along with other items. Our client has the collection, but has not been able to thoroughly record it. He wants to digitally preserve what he can of his collection, especially printed items which can be scanned. It is important to him to attach as much information as he possibly can about each item, including things like images, audio, and video. He would like to be able to search the records of his digital collection based on relevant criteria. Additionally, he would like to share some of his collection publicly online. Other collections, such as museums and libraries, would be welcome to solicit loans from the client. As for our scope of work, again, to quote our client, this collection management system tracks everything the collection curator needs to know about their collections, from item descriptions and provenance, which is a term that means the place of origin or earliest known history of an item, to tracking information that changes over time, such as appraisals, acquisitions, item locations, item loans, and condition. We'll be creating a database that will be able to comprehensively describe all items in the client's varied collection. The item records must be able to accept many different file types. In addition to simple text, the client wants to be able to attach images, video, audio, and PDF files to item records. This database will have three implementations: a web app, an iOS app, and a macOS app. The client is very careful about data backup, so the database will be present both in the cloud and on his local system. This also means a cloud sync feature is a must. The apps will have a user system. Unique users may have different edit permissions and access permissions for the records in the database. If no user is logged in, a portion of the collection flagged for public viewing may be browsed. Users of academic or historical interest may be granted a unique login for expanded viewing of the collection. As with any database, it is crucial to provide a robust, thorough search feature. There are yet several other features specified in our scope of work document. However, I believe the major features outlined here summarize our goals well.
Hello, my name is Raul from Group 1, and I am a team member. For the feasibility analysis, first will be the economic feasibility. Here, the total cost of ownership. This is all estimated. People, including IT staff and users, a basic IT support role might cost around 40,000 to 60,000 annually. Hardware and equipment, a basic server might cost around 1,000 to 3,000. And network equipment might include routers, switches, and cabling, which costs a few $100 to around 1,000. A backup system is essential to protect your collection data, and backup solutions can range from a few $100s to over 1,000. And formal and informal training, including peer-to-peer support, budgeting around 1,000 to 5,000 for staff training is a reasonable estimate. And licensing fees is 500 to 5,000 more, depending on the software feature and choices. The benefits is increased efficiency and improve visitor experience. Software enhances the visitor experience and increases revenue. cost reductions, cost savings in areas such as reduced paper use, energy efficiency, and reduced staff requirements. Also, inventory control software can help catalog and manage the museum's collection efficiently, making it easier to track and locate artifacts. And disaster recovery protects data and information in event disasters, ensuring data continuity. Accessibility enables easy access to collection information for curators, researchers, and staff. And the project benefits of the system outweigh the estimated cost considered total cost of ownership. And organizational feasibility is the organization has staff with necessary technical expertise to lead participate in the project. Management does support, which is essential for project success. And the client does support the project. Their input is valuable to ensure the software meets the needs. And technical feasibility is during the development process of the project, our team has the necessary hardware, software, and network resources. Our team has the experience and skills to complete this project successfully. And for schedules, we've had a rocky start, but we clearly have a lot of work ahead of us. We need to prioritize and plan ahead to make sure we can meet our deadline. We need to make a timeline that will keep us on track and will help us stay focused, sticking with it, while also complete the project within the semester. And thank you.
Hello, I'm Alexander Ochitorena. I'm the project manager for the group LARK, and here's our work breakdown structure. Starting with 1.2, the project initiation planning. We're starting a little late because we've been behind on a few tasks. We're trying to get caught up the best we can. Here we are with defining the requirements, starting that 16th of this month, hopefully finishing the 20th. We really got to crank in to catch up. And that's why some of the dates are a little skewed because we gotta catch up. But hopefully we can. And then we go to 2.4 object-oriented models, 3.1 object-oriented models, 3.2 creating a prototype with the group video, creating a prototype, testing the prototype, and then 4.2 creating a prototype with the creating code, installation plan, training plan, and then making the video. Here's our PERT chart, starting with what we're on currently, 1.2 project initiation and planning, problem definition, get to the group video, 2.2 defining the requirements, we talk to the client, decide if we should buy or build. Then we get to our group video. Then we get to 2.3 traditional models. Start with our event table, ER diagram, context DFD. Make the DFD level 0 to 1. And then our pseudocode, make another group video. Then we go to 2.4 object-oriented models, use case diagrams. Then we get our group video, and then we have 3.1 object-oriented models, we get our diagrams, our security network considerations, and then do our group discussion. Then 3.2, create a prototype. We create the prototype, we test the prototype, we do the evaluation, make a video. Then we go to 4.2, creating the prototype. We create the code, make a test plan, make an installation plan, training plan, post-installation plan, and support plan, and make our group video.
Hello, this is Karen Villablanca, and this is our project scan chart with a visual representation of our project timeline across multiple phases. These phases include project initiation and understanding the problem. In this initial phase, we define the problem definition and project scope, and understanding the problem we aim to solve, and also setting the project's direction. The second phase is planning and analysis, which we're going to focus on detailed project planning, requirement analysis, and feasibility assessment. We are going to define project's architecture and plan the work ahead. Next is the design phase. During this third phase, we are going to create the blueprints for our solution to the problem. This includes the user interface design, database schema, and the overall system structure. In the implementation phase is where we're going to bring our designs to life by writing the code, developing the features, and building the core functionality of our project. Within the implementation complete, we are going to enter the testing and evaluation phase. Here, we are going to rigorously test our system to ensure it met the project's objectives and quality standards, and also submit our final documentations. To view our Gantt chart, start from left to right on the timeline. The included tasks are sequential and have a clear start to finish relationships. The vertical column or grids represent time units, and these colored horizontal bars represent the task. As you follow the bar across the timeline, you can see when it starts and when it ends. The longer the bar, the longer the task is expected to take. Our Gantt chart provides a visual snapshot of the project's progress, and we can easily identify which tasks are on schedule, delayed, and completed. It also provides an overview of the task assignments, enabling us to assign tasks to the team members and track their progress to ensure we stay on track. It's also important to note that we are currently working to catch up with some of the late deadlines, and this will help us identify areas where we've fallen behind and adjust our efforts accordingly. And that's it for our video presentation. Thank you.